Let's try that. Okay, so for this one, predict the number of unpaired electrons in a complex ion. You see 6. And let's just draw this out completely so we're all good. For octahedral, just make sure you label everything. Dx squared minus y squared, the dz squared, dxy, dyz, dxz. Got our delta here. Delta is large or small? Delta is large because Cn, if you look on the spectrochemical series, is pretty far up at the top. And let's see if I have any more pen. Okay, so the other stuff we need here. What's the charge of chromium? It has to be +2 or 2 plus. That's one of the common charges, so that makes sense. So let's see if we have a periodic. Oh, no periodic table here. Okay, so chromium is in column 6, so if it's +2, that's a D4. So we've got 1, 2, 3. Where's the next one go? High or low? Low. There we go. So 2 unpaired electrons, that would be the CFT. It's paramagnetic. There we go. Okay, so that'd be a pretty standard sort of problem for CFT. Since you asked naming, I guess whenever we have something up here, let's try and name it. This is, what do I write first? Hexa, cyano, what's the suffix? 8, because
it's negative.
Yeah, anion. There. Chromate 2. Yeah, I have to name ion if it is ion. That would be the full name. Okay? So whenever naming shows up, we'll give it a shot. Get it this way. I think I have something on color as well. Maybe. Through here. Oh yeah, this is already kind of written out, but it's okay. We can take a look at it and make sense of it. So this is explain the phenomenon. We can name these 2 later for fun. Okay, so we're going to try to explain why these are particular colors. So let's get out your spectrochemical series. That'll be on the back of the exam. I'm looking on the practice exam notes here. And I want to label, let's kind of make an internal column here. I want to know what delta is, and I want to know what lambda is. Okay, so I'm going to rank them from highest to lowest. So what has the highest delta? I believe the one with not NH3, Cl, right? 1, and then NH3, and then this seems really quiet. Let's see. Maybe the batteries are out. No batteries. Doesn't sound that loud in here. Okay, maybe that'll be better. All right, turn that up a little bit. There we go. Okay, what's number 3? H2O, and then I believe this should be 4, right? OH, yeah, that looks right on my spectrochemical series. Okay, so then when it's the opposite way for lambda, this is the largest, because remember, these are inversely proportional. So 1, 2, 3, 4. All right, now I get my color wheel out and see if that matches my color wheel, okay? So let's see. The green one here, the one that appears green, has the highest lambda. That's this one. Okay, now let's go to number 2. It appears blue, and it has a slightly lower lambda. That makes sense. And then the one that is violet here would appear yellow, or would absorb yellow. And so that would be the next one. And then the white one is just completely off the scale. So we had, what were the colors? We had green, blue, let's see, green, we had a blue, we had a violet, and then for whatever reason, this is such a strong field that it goes off the scale and it's white. So it somehow goes through this line right there. So there's kind of a test I'd have to either, you'd be comparing 2 of them would be really common. If there was several of these for whatever reason, then I'd need to give you like 1 or 2 of them for you to finish it up. Okay? So there's a color example. Any questions on that one? Yeah?
Could you explain the relationship between like the delta and lambda?
Okay, these 2 right here. Okay, so from Chem 2A, I'll write it here on kind of scratch. Energy, which is delta is the energy, is, can you see that? Yeah. HC over lambda. So that's one of the equations we saw from there. That relates them. So they're inversely proportional. As delta is getting larger, lambda is getting smaller. So the only reason you'd actually have to use this if I asked you to calculate delta, then you'd use a formula. If not, you're just using it to remember that they're inversely proportional.
Question?
Another question? Yes?
So what would we actually be doing on the exam? Just figuring out which one has a higher delta?
What could you do on the exam? Yeah. Say I give you those 2 on the top, and then I say, one's green, one's blue. Which one's which? And so then you go to the color wheel. You know that the lambda for this one is the largest. So look on the color wheel. There's a green and a blue. So which one would need the higher lambda? Well, reflected through, the green one would need the highest lambda to absorb red. The blue one would need a lower lambda to absorb orange. So this one's got to be green. It would be something like that. Is that all right? So you can't predict color of one individually, but if you have 2 or more, you can kind of predict which color goes with which. Okay, so there's color. Let's see if we can draw something. Oh, let's do some naming of those. So this would be, is it okay if I just say it? So this would be hexa, hydroxo, chromium, chromate, 3 ion. Okay, this would be hexa, aqua, chromium, 3 ion. This would be hexa, carbonyl, chromium, 3 ion, and hexa, amide, chromium, 3 ion. Yeah. Cool. We'll just keep doing that as we arrive on different molecules. All right. We also wanted to do some, we're going crazy on the naming. We also wanted to do some stereoisomers or chirality. I think I have some. Did you already do any of the, I forgot, this might be from exam. Did you already tackle these already, or did we do this in class? No? Okay, this is a great doubles with chirality and everything. Would you like to do these, or just do the naming and things with isomers? Like to do all of it? Okay. Let's try it. What's the coordination number? 6. Yeah, each end counts twice. What's the electron configuration? So what's the charge? Let's do oxidation state first. Doesn't matter what you +3. Okay, cool, because this is each -1. And this has a charge in brackets of +1 because the iodine's -1. So for chromium, gotta look, what's the D what would you put? D3? Okay. Could this be chiral?
Yes.
Okay, yes? Why yes? Yeah, you have, we'll draw that out in a little bit, but it has, these could be cis, and that could force chirality. It has to be cis though. So what Vesper shapes are possible here? Yeah, it's just octahedral. Okay? We could name this, oh my gosh. Okay, this is, what's first? Is it, wait. Yeah, the chlorine comes first. This, and then I don't care if you have parentheses right now or not. So if you want, if you like it, that's cool. Ethylene, diamine. When you write it, make sure the TA can read it. Okay. Chromium. You want chromium or chromate?
Chromium.
And we decided it was +3. Iodide. Okay? We'll draw that out in a minute. Do you want to do more of these? I think the next most interesting would be this one right here. So if we try one more, let's try that one right there, and then we'll try drawing. Okay, so what is the coordination number of this? For oxidation state? +2. D. I'd have to look. 8? Okay, I believe you. Sounds good. All right, could this be chiral? No. It's only octahedral. It's only, well, let's do the shapes first. What are possible shapes? Tetrahedral or square planar. Okay? We don't know, we just know there's 4. Okay. I'll answer your question in just a second. Could square planar ever be chiral?
No.
No. Could tetrahedral ever be chiral?
Yes.
Yes. If?
All of them are different.
Yeah, all ligands are different. Okay, was there a question on what we did so far? Yeah.
So how can you know, like, I know that said if there's more than one name, so can it ever be just kind of not?
Could it ever be square planar, not tetrahedral? In these kinds of problems, I just want you to list both because you don't know which one if you're not given more information. So I'm expecting both answers though. Yeah. Was there? No? Okay. So let's try to draw both. Oh, name it first. Okay. You want which one? Bromo or carbonyl first?
Bromo.
Okay, so dibromo. Carbonyl. Nickel, just nickel? Okay, 2F. That's it. Yeah, when it's neutral, it's just one name, like Madonna. Just one name. Okay? So, now let's draw these. So let's do the nickel first. Okay, let's try the tetrahedral. If it's tetrahedral, what would it look like? So for tetrahedral, if you don't remember from 2A, tetrahedral is the only one you must show dashes and wedges. Okay? The others you don't have to, it's implied by the shape, but you must show dashes and wedges here. Doesn't matter where I put everything. So it doesn't matter where I put these ligands when I draw it. Not at all. If I put, say, if I swap these two, what would that mean? Let's say I swap those two right there. Would it change the molecule?
No, it'd just be on different atoms.
It'd be identical. The only way to change something to make it different, if there was all 4 groups are different. That would make the enantiomer. But if all 4 groups are not different, anything you swap up, you can just rotate in space and be the same. So you better not be drawing another molecule besides this one. If you do, you're essentially like, if you're drawing me, which would be great, it'd be like drawing me a side profile. It's still the same entity, okay? Or from behind, or whatever. So if you drew this, for example, you swap, say, this CO with this BR. These are the same molecule. They're identical. So you better cross one out, or we're docking you a point for the second duplicate. Okay? So don't draw the second one. It's identical. All right. We could also have drawn this square planar. So nickel. So just draw it flat. Okay, is there any other way I could have drawn this one?
Yeah.
Yes, this one for sure. Which way?
Trans.
The trans version. So I drew cis. They're next to each other. Now I can draw the trans. Any other way? No. That's it. Okay? Just cis and trans, that's it. What would happen if I swap these two? Those two right there. It becomes the cis. So that does nothing. Okay? All right. Let's try to draw the other one. That was, what's in the middle? Chromium. So this is octahedral. Remember, these two lines right there mean they're coming towards you. The ones that are kind of going upwards means they're going away from you. The vertical ones are in the plane. All right, so let's see what's on it. We could draw this like that. That's the trans version. Okay? Then, we could have also drawn the cis. So it doesn't matter. Let's say I put one chlorine here. Where do you want to put the other one? We'd like to put it here?
Yeah.
Or here? I mean, it doesn't matter. But for fun, I'll let you pick. You want the one in the back? Do that one? So I think it would look, oh no, yeah, let's see. I just want to get the craziest looking one. Yeah, that's fine. Okay, so EN, there, EN. Okay? Anything else? Cis. The cis can mirror image. Okay? CR, and then I'll get your question after I draw this. CL, and then CL, remember it has to mirror through here. So then we go from the forward one to the bottom, and then the one in the very back. Okay. Okay. So those are enantiomers. Question? Yeah.
If you put the CL on maybe the 4 o'clock position.
Oh, 4 o'clock.
So I mean, how do
You want the CL down here?
Yeah.
And where's the other one? Here. Okay, so where do you want the EN between which 2 points?
however.
You can put one here or one here. Any preference?
No.
Here? Okay. So then it just looks a little funny. This is still 90 degrees, but the EN would be between here and there. Still 90. You can still draw the mirror image. So CL here, CL up top. We've got an EN, which is far away. And we've got an EN going from the bottom to the close to the mirror. Okay. All right, of these 4, which ones would you draw? Either the top 2 or the bottom 2, but not all of them, because they're duplicated. These bound here are duplicates of up above. They're just rotated in space. Question? Yeah.
So I understand that rotate, however, but
The questions about the octahedral or tetrahedral I just did, oh no, square planar. If one was cis and one was trans, that would be impossible to draw. This one trans and trans, they're both are trans or both are cis. Yeah. Okay. Okay. Is this one okay? Yes. Yes.
For looking at the top two,
The top two.
looking at the mirror image, if you rotate the mirror image 90 degrees, it matches the cis. So why is that an anatomy?
Okay, so it'll kind of, for you, these two look similar if you rotate them.
Yeah.
You want to rotate along the vertical axis,
Yeah.
so around here. Okay, so I'm going to ignore these. I'll toss them out down at the bottom. Forget that garbage. Okay? We're going to rotate around here, and you want to go this way?
Yeah.
Okay, so the CL is going to go 90 degrees that way. I'm going to only rotate that one there. Let's move this to the side, so just so I can fit it in here. Okay? So for that one, CR. Okay, this will be the same. This CL will now be here. Okay, the EN now goes from the bottom to here. Right? And then this EN is now in the back. Okay.
Can I see the original cis one more time?
You want to do what?
Can I see the original cis one?
Does it fit? Yeah. Just rotate it 90 degrees, as he said.
How come the bidentate goes to the back? Because like in my mind, I would see it going to in the middle.
The bidentate, this one here?
Yeah, for the rotated one.
Well, it's going to rotate 90 degrees. Remember, it spins along the middle. So, bidentate, let's do it like this.
Question.
Yeah.
You rotated your original cis. How come you didn't rotate your mirror image? I rotated my mirror image to match.
No, there's no reason to rotate both of them. I mean, you can if you want. That's fine. You don't have to. Okay, so the EN in the back. The EN, we're rotating this one. It's right there. I rotated 90 degrees. Now it's in the back. If the EN is represented by these two yellows. It was here. Rotate 90. There.
I understand, but I meant if you rotate the mirror, if you leave that cis as is and rotate the mirror image 90 degrees, shouldn't it match the original cis?
You want to rotate this one now?
Yeah.
Okay, along which axis? The vertical?
Yes, moving this EN to the front and this EN up to the middle.
Okay, we can try that too. It's good practice when you draw. If you're not sure if it's chiral, you got to do stuff like this. So you want to rotate this around the vertical axis. This CL is going to go where?
To go the other side.
Here.
Yes.
Okay, so there's CL on top, there's CL here. We're rotating 90 degrees. If you're looking from the top, it's going clockwise. The EN now is up front. And that's this one. And then this one here is back here. EN.
How do you know that the EN crosses from both sticking out and not from sticking out and going down?
I don't know what that means.
Doctor,
So-
I think you should draw it with like the pegs and the dashes, because that makes a lot more sense for like the 3D.
Yeah, sure, you can do this. That didn't do it for you. Okay, so you're confused about this EN right here? That one?
Yeah, that EN.
Okay.
the way you rotate it, you have your EN going between both, which are coming at you.
Yes.
And why did you know to connect it between
So,
those? And
so the ones, these two right there, are these two, is that okay? This is the EN, the yellow. I'm rotating 90 degrees. So now, these two are in the front, and the end's going from here to here. So it was here, that's the brown drawing there, and the purple one to the right is that. So just rotated 90. Now it's in the back, which represents this one here, down to the bottom. So you want to percolate on that for a while? Okay, you can come play with these or ask me afterwards if you have more questions. Yes?
So the top left, back there, are those chiral?
All of these are chiral.
Because it's by decade, right?
Why is it chiral? Well, there's a couple reasons you could say why. These are not the same. So if you make the mirror image, it's not the same. It's chiral. Also, I know if it's cis, it's got two bidentates on it, it's definitely chiral. So I didn't even think about it, but yeah, so you can do it either way. Yes?
So if you take the one on either one and you kind of flip it, does it go to get the other?
If you rotate these in space, there's no way that they are identical.
So when we rotate, we're all on the same.
You can rotate however you want to.
If you do this, it doesn't work?
Doesn't matter. Okay, last time, we'll do one last rotation. How do you want to rotate this?
I guess the 12 to 6, use that as an axis.
A vertical axis, 180 degrees?
Yes.
Okay, one last time, last rotation. We'll rotate this 180 degrees. There. This one, right? Okay, so. The CL is still there. That one went 180. Okay, 180. Now it's here. You want it here? These are 90 from each other. This is a 90-degree angle right there. Look, you're looking at this. You're talking about these two. These are 90 from each other. 180 is here and here. Okay, you want to percolate on that for a while? Does anybody else want me to draw the rest or move on? Okay. All right, you all think about it. That's why you're going to use these in OChem if you're really struggling with how things are shaped. The same thing's going to happen in OChem. You might as well get a model set. I bought a model set, you know. So, you probably get it at the bookstore. We have an OChem